All right, back to graphing. We graphed last lecture the sine and the cosine, so we got 4 more to go. We have the tangent, cotangent, cosecant, and secant. We're mainly just going to hand do the tangent because that's an important one that you understand. So just as we did with the others, is I have some values here for x, right there, and I'm going to find the tangent of those values. If you remember, we said that the tangent was an odd function. So when you plug in a negative angle, the negative just comes out. And so I just get the tangent of pi over 3. So I'll go find pi over 3. And that's going to be the square root of 3 over 2 divided by 1/2, sine over cosine. So the 2's are going to cancel, of course, and get the negative of the square root of 3. So negative pi over 3, comma, negative square root of 3. I'm going to find the tangent of negative pi over 4. Once again, I can pull the negative outside because it's an odd function. And then the tangent of pi over 4 is just 1. So negative pi over 4 and my negative 1. Negative tangent of pi over 6. So wherever pi over 6 is, here it is. So that's 1/2 over square root of 3 over 2, which the 2's cancel. And I make it look more better. So I get that, but please don't forget your negative sign. So negative square root of 3 over 3. Negative pi over 6, negative square root of 3 over 3, tangent of 0, so y 0 over 1, so that would be 0. So tangent of 0 is 0, my hero. So that says it goes through the origin. At pi, it's also 0 over negative 1, which is 0. So pi 0. And then now I can kind of just look up here because they're just not going to be the negative values. So tangent of pi over 6 is square root of 3 over 3. I'm just looking up chair. So pi over 6 square root of 3 over 3. Tangent of pi over 4 is 1. So pi over 4 at 1. And then the tangent of pi over 3, looking way up here, is square root of 3. And so pi over 3, square root of 3. All right, so once again, I have my x-axis as my angles, and then my y-axis as the value of the function. Now I could entertain you and plot these points and draw a really ugly graph, or I could say, ba-bam, there it is. All right, so what I've done is you're going to see that this actually repeats, and of course that pi, let's go back here, so you can see at 0, I'm through the origin, and then tangent of pi, I'm back at 0. So I've plotted some of these points, but this graph actually repeats like this, and so now you can see at 0, at pi, at 2 pi, negative 2 pi, these are all my zeros. So the domain is a set of all real numbers except odd multiples of pi over 2. Why not pi over 2, you ask? Remember at pi over 2 you'd be undefined, 1 over 0. All right, and so guess what? If I look at the pi over 2's, negative pi over 2, the odd, so then that's 1 pi, 3 pi, 5 pi over 2. These are called the asymptotes. And periodic with period pi. So in other words, if I start here, I go up and I'd start back over here again. Of course, these also go down. There's my intercepts, and once again, my asymptotes. The cotangent looks a lot like it, right? But it's going to be flipped because, again, instead of y over x, it's x over y. The period of the cotangent is pi, not defined for integer multiples of pi, okay, because this one is actually, when you look at the unit circle, you're looking at dividing by the y values. And so all the negative 2 pi, negative pi, 0 of course, pi, and so on, these are going to be my vertical asymptotes. The graph of the cosecant, what this shows is with the graph of the sine. Why do you suppose? Because remember, the cosecant is 1 over sine. And so as you can see, we have, what do you call them things? Asymptotes. We have the vertical asymptotes once again, okay, look the same as the cotangent. And then we have the graph of the secant, where we compare it with the cosine, since it's 1 over cosine. And you can see what's happening is these bases being flipped because it's 1 over, and that gives me those graphs. So they're all important, you know, definitely. I would say that the cotangent, secant, cosecant, you probably don't see a lot in future classes, but you need to know these, and then definitely the tangent you will. And that's a pretty short section, so that's action. Goodbye.